to the cloud. All right, now I'm recording. Yeah. So yeah, I'm gonna remind you of the exercise. So we have the following. So we said 12.5% of New Yorkers are seniors. So that's more than 65 years old. Okay. Now, we know that 14% of seniors in New York, they get the flu shot each year. Right. And we know that 24% of New Yorkers under 65 okay get the flu shot each year. All right, so the first question we had is the following. So A, what's the probability that a person selected at random, or a New Yorker selected at random, of course, is under 65 and get the flu shot each year. Okay. So we have, so the population here is the New Yorkers, okay? And so we are looking for the probability that a New Yorker chosen at random is under 65, and right, so the keyword here is and will get the flu shot each year, right? So so here, like, there are two events, right? So the first event is that the New Yorker is actually under 65. Let's say, so we have the first event, the event A. So the event A is that the New Yorker is under 65. The New Yorker is under 65, right? And we have a second event, let's say F, okay, is that the New Yorker will get a flu shot. So the person, or the New Yorker, get the flu shot each year. Okay, so we are looking for the probability of A and F, right? So we need to find the probability that A and F, so that the person selected at random is under 65, so that will be A, and F F means that the person will get the flu shot each year, right? So that's probability of A and F. So again, so A, this is, so this the A means that the person is under 65, or the New Yorker is under 65. This is under 65, right? And F means that the person or the New Yorker will get the flu shot each year, get the flu shot. Okay, so that's the probability of A and F. Okay, so far so good. All right, now guys, we need to apply our formulas, right? Remember, so for probability of A and B, so that's the multiplication rule, right? So just to remind you, the multiplication rule, probability of A and B, right? So multiplication rule. Multiplication rule, right? So when we have like two dependent events, that will be probability of A times probability of B given A, right? Given A. So the bar here again means that given. So B given A. So in our case, so it's A and F. So there'll be like probability of A times probability of F given A. Okay, so again, A is like, you know, so here is like, this is your A, and instead of B, we have F, right? So we're applying the multiplication rule, probability of A and B. Now, what's the probability of A? A is that the New Yorker is under 65, right? P of A. So that's the probability that New Yorker is under 65. Now, let's see what we have here. We know that, you know, 12.5% of New Yorkers are seniors, so they are more than 65. Okay. So what's the percentage of New Yorkers under 65? I mean, we know that 12.5 are seniors, right? More than 65. So, so what would be the percentage of New Yorkers under 65? Any guess? So the, you know, so New Yorker, that's the you know, your whole population, right? You know that 12.5% of all the population is actually are seniors, more than 65. Okay, so then the rest of the population, right, is under 65. 82.5. Okay. Yep. Yep. So that will be, so the percentage of New Yorkers under 65. So we know that, you know, we know that 12.5% of New Yorkers are more than 65, are seniors, right? More than 65. Okay. So then the percentage of New Yorkers under 65, that will be 100% minus the 12.5%. Okay, so that's the rest of the population, right? So it's 100% minus 12.5%. So that will be equal, of course, as Jinabu said, that's 87, 0.5%. Okay. I mean, a person or a New Yorker is either under 65 or he's more than 65 years old, right? So if 12.5% of the New Yorkers are more than 65, okay, then 87.5 are less than 65. 65, yeah. All right, so that's the probability of A. So that's the 87.5%. Or in other words, if you use a decimal, So that will be 0.875, right? So this is 0.875 times. Now, what's the probability of F given A? So you know that the person is actually under 65. So what's the probability that the person who's under 65 will get the flu shot? Well, let's see. Here it says 24% of New Yorkers under 65. So we know that the New Yorker is under 65, right? So 24% of the New Yorkers under 65, they will get the flu shot. Okay, so given that the New Yorker is under 65, we know that 25% of them will get a flu shot, right? So that's exactly the probability of F given A, given that we know that the person is under 65, right? So given that the person is under 65, there is a 24% chance that he will get the flu shot, right, each year. So that's, so this is actually probability of F given A, it's given, and it's actually equal to this 24%, right? So this is, so probability of F given A, this is the 24%. Okay. So here it's 24% or 0.24. So that's 0.24 here. And so that'll be equal to 0.21, which is take two digits after the dot. So that's 21%. Okay. Any question, guys? So whenever you have like, similar problem and you are looking for some probability, right? Like, I don't know, like in this case, a New Yorker under 65 and he will get a flu shot. So my advice for you guys is first to write down the events, like, well, under 65, that's like my event A, get the flu shot, that's like my event F, right? We have like two different events. And then you need to check which formula you're going to use, right? So like in this case, we have the word, in the problem, we have the word and. Okay, so this is like probability of A and F, or probability of A and B, okay, or wherever. So once you have the word and, it means that you need to apply the multiplication rule. Okay. All right, so then if there are no questions, for B, I think we had the following for B. So what's the probability again that a New Yorker selected at random, etc., is a senior and will get the flu shot each year? So what's the probability? Probability that again, a New Yorker selected at random is a senior. So more than 65, and then and is senior and will get the flu shot. Each year. All right, so the same thing. Well, here we have two different events, right? A New Yorker selected at random is a senior. So being a senior, that's like my first event. So that's like my event S. So event S. So the person or the New Yorker is a senior. All right, That's my event S. And then, so the keyword here is and, get the flu shot, right? So again, this is, so that will be the same event as the previous problem or previous question. So event F, so the person will get a flu shot. So we are looking for the probability, right? The probability that the person selected on random, etc., is a senior and will get a flu shot, right? So that's the probability of S being a senior and will get a flu shot. So and F. So that's the probability of S being a senior and F get flu shot each year. So again, this is just, again, it's a multiplication rule. So S and F, so that'll be like probability of S times probability of F given S. Okay. Now, what's probability of S, of being senior, probability of S? So that's the percentage of seniors in New York, right? So so as you can see here from the first sentence, 12.5% of New Yorkers are seniors, right? So when you select a person or at random, there is 12.5% chance that the person is actually a senior, right? That he has more than 65 years, right? So yeah, so that's the probability of S, right? Being senior. So you have 12.5 chance that a New Yorker is actually a senior, right? So this is probability of S is just 12.5%. Right? Now, probability of F given S. Okay, given that the person is a senior, what's the probability that he or she will get a flu shot? Well, let's see here. So as you can see, 14% of seniors, so we know that the person is a senior, or he or she is a senior, right? So 14% of seniors will get a flu shot. So the probability that the person would get a flu shot, given that he is or she is a senior, is 14%. Right, so this is equal to 14%. Yeah, so then the answer would be this S and F. So probability of S again times probability of F given S. So that's probability of S. We said 12.5% of New Yorkers are seniors. So that's the probability that the person is a senior times the 14%, because there is a 14% chance that a senior will get a flu shot each year, right? So in other words, this is like 0.125 times 0.14. So that'll be equal to 0.01, I think, 75. 0.175, yes. All right, so to convert this to into the percentage, again, you take two digits after the dot, so that will be 0.1 or 1.75%. Okay. Any question, guys? So this is, I think, I'm not sure how many problems we did last time. I think we did a couple of problems, right? This is probably like the third how many problems? Yeah, I think we had like 2 problems. We did like 2 problems on Monday, right? And this is like the third exercise. Yeah, I think we did a lot of exercises in this section, right? The 3 exercises, I think it's probably enough. But anyway, we don't have much time, so we need to move anyway to the next section. But is there any question, guys? So again, the idea here is, you have to find like the keyword, right? So you're looking for some probability, right? And you need to find like the keyword, which is probably and or, right? And then you need to apply like the right formula. So for again, if you have like here in this problem, we had probability of A and B, right? So then we use a multiplication rule. So if you have like or probability of A or B, then you need to use the addition rule. Okay. All right. So yeah. So let me move to the next section. So we're gonna move to the new chapter, actually, chapter 3. Sorry, chapter 6. Okay. All right. So this is chapter 6, section 6.1. All right, guys. So in this section, we're gonna discuss random variables. So this is introduction to random variables. And probability distributions. All right, so before the examples, guys, what I'm gonna do, I'm gonna introduce, I'm gonna define what's a random variable and what's a probability distribution, all right? And then I guess we're gonna have a couple of examples. So let's start with the definition of random variable. So a variable x is a random variable if the value that x takes on in like an experiment is just a chance or a random outcome. So a variable x, so the value of x, so variable x is a random variable. So this is why it's called a random, because the value of x can be just a random value, a random variable. If the value that x takes on in in a given experiment or observation. So in an experiment, is just is a random outcome. Okay. So in other words, the value of x is just some random value. It's going to be just some random value. Now, we're going to distinguish between 2 kinds of random variables. There's a discrete random variable and continuous random variable. So in the discrete random variable actually is going to take on only a finite number of values. Okay, so so first we have the discrete random variable So discrete random variable so discrete random variable can take on only a finite number number of values. So for example, so let's say X is the example. Well, let's say X is the number of students in the in the classroom. Okay, and let's say that the capacity of the classroom is let's say 30. Capacity of the classroom is 30 students. Okay, so X, the number of the students in the classroom, well, X can be equal to, for example, in this example, can be equal to, it can be equal to 0, or you can have just one student, in the classroom, or 2, or 3, or 4 students, etc. Right? And the maximum number of students you can have in the classroom, of course, because of the capacity, is 30, right? So as you can see, the possible values of X. So how many possible values for X? Well, we have 1 value, 2 values, 3 values, 4, etc. 31 values. So X can take on only 31 possible values, right? So in this case, X is a discrete random variable, right? Because the total number of possible values of X is it's actually 31. So there are only let's say 31 possible values that X can take on. Okay. So in this case, the variable X is called a discrete. So X is a discrete random variable. So then X is a discrete random variable. Okay. Now, the second kind of random variables is called continuous random variable. So we have the discrete random variable, and then we have continuous random variable. So 2 continuous random variable. So actually, in this section, we're going to be interested in discrete random variables. But next, in the next, I think next chapter, we're going to focus on continuous random variables. But yeah, so what's a continuous random variable? Well, a continuous random variable can take on any value in an interval. So a continuous random variable can take on any value in an interval. Okay. So I mean, in other words, the X. X, of course, here the variable is X, can take on any value in interval So the value of x can be, for example, real number or decimal. So for example, so x can be decimal. Okay, so like here, in my example, with the number of students, as you can see, we have just so the number of students, it's a whole number, right? It's an integer. Now, for continuous random variable, the value of x can be like a decimal. So for example, let's say x is the time. Example. X is actually the time. The variable x is the time it takes to get on campus. On campus. Okay, and let's say x is the unit here for x is, let's say, minutes. In minutes. Okay. I mean, for example, your x can be any. So x, the value of x here, it can be any value in an interval, right? So for example, x can be, I don't know, for example, x can be equal to any value in, let's say you live in the Bronx, okay? So let's say the maximum time it takes to get on campus if you live in the Bronx is, let's say, 3 hours, okay? So then x can be equal to any value in the interval let's say from 0 to I don't know, 3 hours. So 1 hour, that's 60 minutes. So 3 hours, that will be 180 minutes, right? Let's say, for example. Okay. So for example, x can be, I don't know, for example, 22.5 minutes. Right? It can be a decimal. And I mean, from 0 to 180 minutes, you don't have a finite number of values. Because you think of 0 to 180 minutes, to think of 0 to 180 minutes as an interval, right? So we have like this, your number line, this is 0, this is 180, right? So we have like continuous interval, and your x can be any value in this interval. So for example, this is your x, and it's equal to 22.5, right? So the idea here, guys, is that in this interval, from 0 to 180 minutes, you don't have a finite number of values. You have infinite number of values, right? Because, again, your x can be a decimal. So it can be like 22.5 or 22.51 or, So here in this interval, we have infinite number of numbers or infinite number of values. Okay. So this is different from discrete. Remember, the discrete number of students, it's either 0, 1, 2, 3, 4, etc. And the maximum would be 30, right? Here, you don't have like a finite number of values. It can be any value in this interval. Okay, and in this interval, there are like infinite number of values. All right. I mean, from 0 to 180, it's not just like 0, 1. You don't just take like the whole numbers. You can also have like decimals, right? Or rationals, etc. So you don't have just like whole numbers. You have also decimals, you have rationals, etc. So that's why we have like infinite number of values in this interval. All right. I mean, I hope this makes sense to you guys. So that's the difference between discrete and continuous random variable. All right, so that's for a random variable. Now for the definition of a probability distribution. So for the probability distribution, well, probability distribution, guys, it's just an assignment of probabilities to each value of your random variable. The probability distribution So what we do, we're going to assign a probability to each value of x. So probability distribution is an assignment of probabilities to, well, of course, if you have a discrete random variable, you're going to assign a probability to each distinct value of your discrete random variable. So to each distinct value of the discrete random variable. Okay. And let me just say here, guys, a remark. The sum of all the probabilities here is going to be equal to 1. So the sum of all assigned probabilities must be equal to 1. Okay. Now for when we have a continuous random variable, so what we do, you're going to assign a probability to each interval of values. So to each interval of values of the continuous random variable. Right. So let's have some examples. Let me show you now with an example. What do I mean by this probability distribution and etc. So my first example. Let's say we're gonna measure the boredom tolerance. So we're gonna measure. So we measure, let's say, the boredom tolerance, and let's say we have like seven different boredom levels. So boredom levels. So we have 0, let's say 1, 2, third level, 4th, 5th, and 6th. And let's say 6. This is like the highest. 6 is the highest tolerance for boredom. Okay, 6 here, the level 6. So this is the level 6. This is the highest tolerance for boredom. Okay, and then let's say we have a survey of so let's say we have like 20,000 people. They took this boredom test. Okay, and then we have the following results. So let's say 20,000 people took the boredom test. Okay, and we have the following results. So, so the results are the following, right? So we have, again, we have 7 different boredom levels. So here, so this is the boredom level. And here, the number of people. So for example, let's say the number of people with the boredom level equal to 0 is 1,400. So we have 1,400 people with boredom level equal to 0. Boredom level, let's say 1, we have 2,600. Boredom level 2, we have 3,600. So 3, of course, I need 4, 5, and then 6. Level 3, we have, let's say, 6,000. Level 4, we have 4,400. Level 5, we have 1,600. And level 6, we have 400 people. Of course, the total number of people is 20,000, right? Because we have 20,000 people who took the boredom test. All right. So I'm gonna define x, my variable x, as, so x is gonna be equal to my the boredom level. My variable x is the boredom level. So my first question for you guys, do you think this x, is it a discrete? Is it a discrete random variable or a continuous random variable? Do you think it's a discrete or continuous? This x, the boredom level.
It is.
So remember, discrete, it means that x can take on only a finite number of values, right? And continuous, that's when x can take on any value in an interval. So what are the possible values of x here? The possible, because x is a boredom level, right? So the possible values of x are, you know, just a 0 or 1 or 2, 3 or 4 or 5, 6, right? I mean, x here is or can be equal to, is equal to 0 or 1 or 2, 3, 4, 5 or 6, right? So how many possible values x can take on here? Well, as you can see, there's 1 value, 2 values, 3 values, 4, 5, 6, 7. So there are 7 possible values for x, right? And 7 values, 7 possible values, that's a finite number of values, right?
Yes.
That's not infinite. I mean, you have just 7 possible values, right? So x here can take on only 7 possible values. Okay, so that's just a finite number of values. That's a finite. So that's a finite number of values. It's not infinite, right? We don't have like infinite number of values, possible values, just finite number of values. Finite number of values. Okay, so then x is a discrete. It's a discrete random variable. Okay. All right, now, so that's my variable x. That's a boredom level, and it's actually, it's a discrete random variable because it can take on only 7 possible values. That's a finite number of values. All right, so what I'm gonna do now, I'm gonna assign, so now I'm gonna try to find, so I'm gonna find my probability distribution. Okay. So how do we find probability distribution? Well, so what does it mean, this probability distribution, right? So what we're gonna do, we're gonna assign for each x the probability of x. Okay, so we're gonna assign for each x, for each value of x, for each value of x, possible value of x, we assign the probability of x. Okay, so for example, x, first value of x is 0, right? That's the first boredom level, it's 0. So what's the probability that x is 0? So p of x equal to 0, this is a probability that a person selected at random has a boredom level equal to 0, right? So this is, let me write it down here in words. So this is the probability that the p, of course, the capital P, guys, stands for probability, right? Probability that x is 0. So probability that x is 0, this is the probability that, you know, a person selected at random, of course, right, has a boredom level equal to 0. Boredom level equal to 0. So that's what I mean by p of x equal to 0. Now, what's the probability that a person selected or chosen at random has a boredom level equal to 0? Remember, how do we compute the probability, right? That's the frequency of the event over the size of the sample, right? Just to remind you of the formula for the probability. So we have, you know, the frequency over the size of the sample. That's how we compute probabilities, right? Size of the sample. So again, frequency, it's you count how many, like in this case, you count how many people with boredom level equal to 0. So how many people with boredom level equal to 0? That's the 1400, right? Out of the 20,000, we have 1400 people with boredom level equal to 0. Out of the 20,000, right? So this probability that x is 0, that's the 1400. That's the number of people with boredom level equal to 0 over, of course, the size of the sample. We have 20,000 people in total, right? So that's 1400 over 20,000. Does this make sense to you guys? The 1400 over 20,000. I mean, you see why it's 1400 over 20,000, right? That's 1400. That's the number of people with boredom level equal to 0. Right. This is the number of people with boredom level equal to 0, and this is, of course, this is the total number of people. Total number of people. So yeah, anyway, so when you divide the 14 over 20,000, I think you get, this is equal to 0.07, right? So this is, again, this is a probability that x is 0. So what I'm gonna do, I'm gonna assign to the variable x equal to 0 the probability that x equal to 0. So that will be the 0.07. Of course, we can do the same with the like x equal to 1, right? Probability that x is equal to 1. That will be, of course, the number of people with boredom level equal to 1. We have 2,600 over the total number of people, that's 20,000. And I think this is equal to 0.13, etc. Right? The probability that x is 2, number of people with boredom level equal to 2, that's the 3,600 over total number of people, and that will be 0.18, etc. Okay, so then my probability distribution, so the answer, so the probability distribution is the following. probability distribution. So it's going to be the following table. So we're going to have, so here we have X and here we have P of X. So X can be 0, can be 1, can be 2, can be 3, 4, 5, and 6. Now we said probability that X is 0, that's 0.07 or 7%. Right, so it's up to you guys. You can use a percentage or decimal. So for if you use decimal, so this is 0.07. 1, we said the probability that X is 1, that's 0.13, etc. Then we have 0.18. For 3, we're going to have 0.3. For 4, 0.22, 0.08, and 6, that's 0.02. So you see what I did, guys? For each value of X, for example, here, X is 3, I assigned the probability that X is equal to 3. So this 0.3, this is the probability that X is equal to 3. Okay, so that's 0.3, which is, of course, the number of people with boredom level equal to 3. That's, I think it's 6,000. We have 6,000 people with boredom level equal to 3 over the 20,000. Right, that's how I got the 0.3. All right, so that's what I mean by probability distribution, right? This table or this chart, this is exactly what I call the probability distribution. So for each value of X, you assign a probability of X. Right? Any question, guys? Does this probability distribution make sense to you? So for each X, you need to find like the probability of X, right? Now, as I said, as a remark, for probability distributions, I mean, for discrete random variables, the sum of all the probabilities of X is going to be equal to 1. So here, just a remark, the sum of all the probabilities of X is equal to 1. All right, so remember, guys, this is so this is a capital sigma, right? This is a summation, right? So what I'm saying here is that, so if you do probability that X is equal to 0 plus probability that X is equal to 1, X is 3 plus probability that X is 4 plus probability that X is 5, probability that X is 6. The 6, of course, is the last possible value of X. So I claim that this is always equal to 1 or 100%. Okay, so if you do the sum here, 0.07, etc. So again, so this is 0.07 plus 0.13, 0.18. So this sum is going to be equal to 1. So I claim that this is actually equal to 1. All right. Yeah. All right. So that's for the probability distribution. Now we're gonna graph this probability distribution. We use the histogram. Remember, we use the histogram to display the frequency and relative frequency sometimes, depending on the problem. So this probability of X, this P of X, this is actually, this is just a relative frequency, right? Because remember, guys, when you divide the frequency by the size of the sample, frequency divided by the size of the sample, or the total number of data values, that's exactly the definition of relative frequency. Okay, so this formula here, this is just a relative frequency. So what I'm gonna do, I'm gonna graph now. So I'm gonna show you how to graph. So graph probability distribution. right? So because so this P of X, this probability of X, this is just the relative frequency. So I'm gonna use a histogram to display, this relative frequency. Okay, so let's graph this probability distribution. So again, it's going to be a histogram. So we have so a horizontal axis. So here in the horizontal axis, that will be the values of X. Values of X, we have like, that's the boredom levels. So we have boredom level equal to 0. We have 1, 2, we have 3, 4, 5, and then 6, right? Now, on the vertical axis, I'm gonna put the P of X, or again, P of X is just the relative frequency. Okay. So P of X, let's see the values of P of X. So as you can see, the smallest value of P of X would be like, this 0.02, and the largest value of P of X would be this 0.3, right? So we're gonna need 0.2 somewhere. So let's say this is like my 0.02, I mean 0.02. Let's say this is 0.05. Then we have 0.1. This is 0.15, 0.20, 0.25, and then 0.30, or 0.3. All right, so how do we graph this histogram? So for X equal to 0, P of X is 0.07, right? So if X is 0, P of X is 0.07. So I'm gonna do, guys, I'm gonna draw like an interval with the 0 in the middle of the interval. So you see, here's my 0. 0 is supposed to be my X, right? So I'm gonna draw like an interval with the 0 in the middle of the interval. Like, so I'm gonna take this red interval. Okay, and as you can see, the 0 is in the middle of my interval. And now I'm gonna draw like a rectangle with the height equal to 0.07. So we're gonna need to go 0.07. So that will be probably somewhere right here. All right, so here again, this is like 0.07. All right, and again, here's my 0. Probably I can have more here on this side. Okay. Now, for 1, X equal to 1, the P of X is 0.13. So I'm gonna take 1. I'm gonna draw an interval with 1 in the middle of my interval. Okay. And I'm gonna draw the rectangle with height 0.13. So we're gonna go up to 0.13. All right, so this is, so here's somewhere here, this is 0.13. All right, etc. So for 2, we're gonna go up to 0.18. That's the probability of X equal to 2. So here I'm gonna draw this interval with 2 in the middle, and with the rectangle up to 0.18. Okay, so here this is 0.18. Again, 2 is in like in the middle of this slide here. All right, for phi, I think the P of X is 0.3. So I'm gonna take this interval with the phi in the middle. I'm gonna go up to 0.3. Sorry. So 0.3 right here. Okay. Now for 4, it's a 0.22. So we have this interval up to 0.22 up here. Uh, 5, we have 0.08. So 0.08 probably is going to be somewhere right here. And finally 6, it's 0.02 for 6. So it's going to be probably somewhere right here. Okay. Again, here's the, this is 4 right here, this is 5, and here's 6. All right, so this is the graph of this probability distribution. Let me just make one remark, guys. You know, each bar here is like 1 unit wide. So the area actually under the graph. So you see this graph here. So the area under the graph is going to be equal to 1. That's because the sum of all the probabilities is equal to 1. So just a remark here, the area under the graph, you know, this graph right here. So the area under the graph is going to be equal to 1. Okay. Well, I mean, we're gonna use this in the next chapters. I mean that the area under the graph of this distributions, probability distributions, is actually equal to 1. This is actually a very important remark. Anyway, is there any question, guys, about this graph of probability distribution? So it's just the histogram, but here, because we have this discrete. Remember, like for when we make the frequency table and then the histogram. In the frequency table, we have like, you know, our class's limits or class's boundaries. So we have like intervals, right? We had intervals. And the thing is, here we don't have intervals. Here we have just a finite number of values of x, because our variable here is discrete, right? We don't have intervals, so we don't have like class limits or class boundaries, classes boundaries, right? So that's why we put like the x in the middle of your, of your interval. Okay, and then you draw your rectangle. Any question, guys? All right. So let me just, so this is the graph of this probability distribution. Let's have an exercise. I don't, well, how much time do you have? Well, okay, I have like 7 minutes. Well, before the exercise, let me just say here, guys, we can, of course, we can have some questions, about, the probability of, for example, of randomly choosing someone with boredom level, 0 or 1, where we have to use like our addition or multiplication rule, right? So, for example, here, let's say this is a question. Let's say you want to find the probability. What's the probability of choosing someone? Probability of randomly, of course, randomly choosing someone, choosing someone with boredom level 0 or 1. Okay. So here, of course, the keyword would be or, right? It's a 0 or 1. Okay. So what we are looking for is the probability that x is 0 or x is 1, right? Your boredom level is 0 or 1. So x is 0 or x is 1. Now, when you have or, of course, we need to use, just to remind you, the addition rule. So A or B, that will be probability of A plus probability of B minus probability of A and B. So in this case, like in this problem, A would be like the x equal to 0, and the B would be the x equal to 1, right? So that's the probability of A. A is x equal to 0, so probability of x equal to 0, plus probability of B. B is x equal to 1, so probability of x equal to 1, minus probability of A and B. So here A and B, guys, it means that x has to be equal to 0 and 1 at the same time, right? So a person has a boredom level equal to 0 and 1 at the same time. And of course, that's not possible. I mean, you have either boredom level equal to 0 or boredom level equal to 1, okay? X cannot be equal, boredom level cannot be equal to 0 and 1 at the same time. So it's either 0 or 1, right? So this A and B, that's not possible, just 0. Okay, so here, probability that x is 0 or x is equal to 1. So it's just probability of x equal to 0 plus probability that x is equal to 1, right? So so that will be, so probability that x is equal to 0, that's, you can just find from our probability distribution, that's the 0.07, right? That's probability that x is 0, and probability that x is 1 is this 0.13, right? So that'll be 0.07 plus, so that will be probably 0.07 plus the 0.13, so that will be 0.2 or 20%. Okay. All right. You have a few minutes. So we need to do an exercise, one exercise at least. So I'm gonna, in the last 3 minutes, guys, I'm gonna write down an exercise. So next time, Monday, next Monday, I'm gonna try to go over this exercise. But of course, I'm gonna assign a new homework. I will post it tomorrow on CUNY Blackboard, and it will be due next week. But if you have time, you can think about this exercise, and I will go over this next time. Okay. So this exercise is about. So we have, let's say. So we have, let's say, 100 committees in the college. Let's say in BCC. Okay, and let's say X, that's the number of professors in the committee. Okay. And so we have the following survey. So here's X, and here is the number of committees. Okay, so let's say we have like 20 committees with only one professor. Again, X is the number of professors in the committee, right? So let's say out of the 100, we have 20 committees with only one professor, 25 committees with two professors, 5 committees with 3 professors, 20 committees with 4 professors, and 30 committees with 5 professors. Okay, so what do we have to do, guys? Okay, give me just 30 seconds to write down the questions. So first, you need to find the probability distribution. Of course, here X is going to be a discrete random variable. And then 2, you need to graph the probability distribution. Okay, graph the probability distribution. And 3, what's the probability that a committee, of course, selected at random, has, let's say, 3 or 4 professors. Okay. All right, guys, I'm gonna stop here. Sorry, it went over time. So yeah, so next time, I guess we're gonna discuss the mean and the standard deviation of this probability distribution, and then yeah, and then I think we're gonna practice a little bit. We're gonna have a couple of exercises, and then we can move to the next section. All right, thank you for listening, guys.
Professor, the homework,
yeah, please.
The homework that you're gonna post will be due next week Wednesday, correct?
Yeah.
Okay, thank you.
Thank you everyone. Thank you for listening.
Have a good night.
Yeah, see you next time. Take care.
Bye.
Bye.